AI data centers are a hot button issue. There's lots of yelling, lots of social media comments, lots of news articles, lots of municipal issues, government issues. There's some suing going on. I saw something this morning. It's a big, big mess. But data centers have been around for a long time. And I want to talk about data centers. I want to talk about data centers. I want to talk about AI data centers. I want to talk about all this kind of thing. I did a bunch of research for this, and I found out that this topic is just absolutely massive. I have so many different sources that I've used, and some of them I've used like a single line, and there's a whole bunch of other information, but I've got a whole bunch of other information from another source. And so I want to talk about AI data centers. Are they good? Are they bad? Do we need data centers? What are they? Let's just sort of set the record straight. Let's have a conversation and let's do this episode. So if this sounds interesting to you and you want to support the show, you can go and check us out on that Patreon, leave a review or rating on your podcast app, join us in our Discord server, share this with your friends. And if you want to learn how to code, you want to do some courses on how to code, please do so using our link to net yourself up to 20% off a Scrimba Pro plan. You can do so with our link again, that's in the show description and in the show notes, with full details on how it works in the show notes on htmlallthethings.com. Now, I just want to kind of give a disclaimer or just sort of how I want to structure this episode. I mentioned in the beginning that this is a hot button issue, especially AI data centers, hyperscalers, all this stuff, like hot button to the point where like people are like really pissed. I mean, just straight
issue. Like it's a full-on political issue where like people are taking sides and stuff.
People are taking sides. There's environmental problems. There's municipal problems and everything. So what I want to do in the beginning of this, and I know that we've kind of converted this podcast to be more conversational, but I just want to set the record straight right off the hop with some definitions. So I've kind of wrote out a section that's defining what a data center is, what a hyperscale data center is, what a hyperscaler is, and what a neocloud is. And then we'll jump in and kind of converse on the various hot button parts of this. I do also want to say something again. I mentioned in the beginning, there's been a ton of sources and a ton of information. We're not covering everything. So I'm not saying that these are the only issues. I'm not saying that the issues that we're like, if we talk about economic impacts, whether I'm talking about the biggest economic impact of all the economic impacts that they have, there are a ton of things going on. This is like an all gas, no brakes situation. This is a total disaster, which we'll talk about, of speed and panic, it seems like. So I'm going to, again, read these definitions first, and then we'll get into it. And we might have another data center episode in the future if you guys like this one, because, again, there's just a ton of stuff going on, and it's ongoing as well. This is an ongoing thing. So what is a data center? Let's knock that definition out right away. A data center is a collection of computers and networking equipment housed inside of a centralized location. They provide cloud computing capabilities for everything from web hosting through social media apps. A common example would be photo backups. It's very common for someone to back up their photos to a service like Google Photos or OneDrive. And when you do this, you're storing your photos in an infrastructure that uses at least one data center. In a very simplified case of Google Photos, you can take a photo with your phone, and then it will upload that photo to one of Google's data centers, where your photo sits on a storage device somewhere inside that data center, ready for you to access it from any of your internet-connected devices. Now, again, I said that's simplified, so what are some complexities? Well, some common data center complexities, some, not all, of course, is for security purposes. Your photo may not actually just be stored on a random hard drive or SSD somewhere in one data center. It may be stored piecemeal across multiple data centers, and this is to prevent things like a physical break-in at one single data center from becoming a data breach. Someone breaks in, they steal that one hard drive, well, now they got like a quarter of an encrypted photo, and they don't really know what this whole thing was. They not only do they only have a piece of the map, it's encrypted generally, so it's a security thing. And also for quick access, this is another complexity. For quick access, your photo may be stored in multiple data centers, so in more places than one. And this is to allow you to quickly access it wherever you are geographically. And we've seen this with the likes of Netflix. So for example, when Netflix was first getting started, they'd have the most common content, maybe, I don't know, House of Cards or something. The stuff that was common, the stuff that was really popular in the early days of Netflix, they would actually have those sometimes housed inside ISP data centers or ISP networking hubs because it was quicker to access those. And you might even notice, although it's just seconds, so you probably wouldn't, but you might even notice, let's say you were watching House of Cards, you press play, it would maybe play in a second. 1 second, it would start playing. But then you really like this niche movie, it's on Netflix, you click it, it may take 5 seconds to start. That's because it might be grabbing the data from somewhere across the country from a different data center. And so geographical location is another data center complexity. Data centers are located in a variety of facilities. These range from things that look like huge warehouse-like buildings through smaller, nondescript commercial structures that sit in amongst offices in business parks. Now, data centers have been around for decades, and with the rise of cloud computing, of course, they have grown in the amount of them and the power of them and what we use them for. Now, full disclaimer as well, I've worked in data centers. I've been in data centers several times. I've worked on the servers. I've worked on the power. I've racked servers is what we refer to it. I've racked servers, et cetera, et cetera. This was over 10 years ago, so I haven't been a part of any hyperscalers or anything like that, or even AI. That wasn't really a thing back then. But I do know what I'm talking about when it comes to data centers, at least at the basic level. So I mentioned hyperscalers. What is this? What is a hyperscale data center? Now, I do want to say something here that both terms, hyperscale data centers and hyperscalers, have been around since before the AI boom. So I actually found a podcast describing what a hyperscaler was, what a hyperscale data center is from 4+ years ago on YouTube. And I was like, oh, this is like before the AI boom. So this is interesting because this term is usually associated with AI, and there's good reason for that, but it's not only AI. So what is it? Hyperscale data centers are massive data centers that are engineered for large-scale workloads across optimized networking capabilities. They offer extreme scalability capabilities. So something like I might go from needing 1 computer to 500. The thing is, though, is the customers aren't even referred to as how many servers they use. They're often referred to in sort of megawatts, which I'll get into in a second. These huge data centers, these hyperscale data centers, are commonly used for AI, automation, data analysis, data storage, data processing, and other large computing needs. Now, the scale disparity of a hyperscale data center versus a traditional data center is quite large. So in this podcast, and I'll link to all these sources that I found, but in this podcast that I listened to, they were referring to customers, again, not in, hey, this guy needs 5 servers. This guy needs 128 cores worth of CPU power. They were referring to them as a megawatt customers in a way where they'd say, that's a 10 megawatt customer that may go up to 30 megawatt customer. And you can start to see the controversy coming up. Water usage is one of the things. Electrical usage is another. So now all of a sudden you have somebody who's running an app, let's say, they're hyperscaling it, and they know how I'm a startup today, I need 8 megawatts, which is quite a bit, But in the future, I might need 45, I might need 30. And I'm not a data center company, I run this app. So you would go to a hyperscale data center provider, and they would set you up. Now, when it comes to traditional data centers, you may look at different things. So you may look at how many servers they're using. You may look at how much bandwidth, or how many websites could this thing host, how many hypervisors you'll need, right? But that's not the case with hyperscale data center. It's often done in sort of the megawatts or these huge numbers. I was talking to Mike actually previously. It was actually yesterday. Him and I were talking. I used to work at an industrial bakery. And this is, cooking at a scale that isn't even recognizable. If you go to make some muffins, for example, in your home, you might need 2 eggs for the recipe. And so you might think, oh, well, when they make it at an industrial scale, maybe it's 10 eggs. I don't know. No. We had like a plumbing infrastructure for eggs. We had a big old egg tote, and you'd pull a valve, and egg was filling the tote, and it would get pumped through pipes, and then you would dump a certain amount of egg into the batter, and it would be generally done in like pounds. Like, I don't need 10 eggs specifically. I need 10-pound eggs. I need 30-pound eggs. So it's such a scale. Hence hyperscale. It's such a difference that's kind of like a different industry, but the same kind of example is like that's cooking at a hyperscale level versus you using 2 eggs in your kitchen to make like a Quaker muffin mix kind of thing in your home. Now, hyperscaler, it's used interchangeably with hyperscale data center. However, hyperscaler actually is a term used to refer to cloud service providers, sometimes called CSPs, that provide hyperscale data center services. Common ones are very popular, and you've probably heard of them: Amazon's AWS and Microsoft's Azure. They're hyperscalers. And then the last thing, this is like a newer thing, really quick. You might start hearing the term neoclouds. This is another form of data center that is focused on offering GPUs as a service. It's kind of an AI first type of thing. It's just starting to get started. I'm not going to get into the weeds with it. I think we have enough sort of context here. So with all this being said, lots of different types of data centers, lots of different type of thing. AI data centers. Well, in 2026 and the previous few years, AI computing, meaning chatbots, image generation, code generation, the list goes on, it's been made available to the public. And this computing is almost all done in the cloud, meaning that the need for AI data centers is growing exponentially. Due to the speed and scale for the need of these data centers, we're starting to see several issues come up, including in areas such as economic, environmental, and local or municipal concerns. And I just want to say one final thing before Mike and I kind of jump into the conversation of this episode is you might say, well, what's an AI data center in comparison to a data center? In comparison, basically, you kind of have to think of it as AI is hyperscaling right now. So they'll generally be in a hyperscale data center where we need so many megawatts. We're all in a race. All these companies are in a race. So yeah, AI could run in a traditional data center, assuredly, but you're going to not be able to keep up with the ChatGPTs and the Groks of the world. Everyone is sort of build, go. And so they fall into AI data center commonly falls into the hyperscale data center, at least right now, because they need so much power and so much space and so much water and so much compute. And remember, it's not like AI has taken over everything to the fact where we're no longer using Google Photos and things. Our existing infrastructure still needs to exist. More people on the planet as well, more people getting online. So now you have to grow the traditional stuff. And now you have this sort of new thing on the side, and you can see where the controversy begins. This is like an all gas, no brakes, everybody full force. Go make data centers. Go.
I think a big difference between those traditional data centers that we had before for the Google Photos is versus what we have now with these hyperscalers and whatever you want to call the AI neoclouds, whatever you want to call the AI data centers, is the compute required. So the Google Photos compute was mostly storage related. Obviously there was some ingress, there was some, computing for fetching a photo and showing it, whatever. But that's astronomically lower compute requirements versus running an LLM, or even worse, training an LLM. So the data centers that we're seeing now are being powered by massive power generators, massive power generators, because of the fact that each one of these each one of these servers has X amount of graphics cards. And if you know anything about gaming, if you know anything about building computers, you know that the graphics card usually is the thing that, first of all, costs the most in a computer, and second of all, uses the most power. And it goes the same way in a data center where typically beforehand, before we needed these massive compute data centers, not every server would even have a graphics card. A lot of them would be CPU based. You would have 2 or 3 CPUs inside of them, and that would be enough for you to, power all your SSDs and all of your data and storage and ingress and bandwidth and stuff like that. Now it's a requirement for a server to have pretty much only graphics cards. Who cares about the processor? Who cares about the storage? The only thing that those serve is to support the graphics, the raw power, so that it can get as much out of it as you possibly can. So we've had this shift coming from traditional data centers of storage and data processing to massive requirements for compute. And that's not an easy shift to make from both an infrastructure perspective and from a hardware perspective. That's a very different requirement. We obviously had these before, by the way, before LLMs, before 2022, ChatGPT, we had AI massive Watson type machines that required a lot of graphics card power.
Supercomputers, comparable to exactly the idea of a supercomputer.
And this is making a massive supercomputer and cluster, a supercomputer cluster that's accessible to the general public. right? Like that's what we're seeing right now to a certain degree. It's not exactly that, but like it's a pretty big shift in a lot of different ways. And I think you're going to get into it right now, like with environmental and economic and all that. But like we're, we are seeing a foundational shift in what the requirements are, and we don't know where the top is right now. Today, actually, I was reading that OpenAI has acknowledged that, hey, like the amount of compute required for these models is starting to become ridiculous. Like it's starting to become too expensive for companies. Like we're
Of
starting to see
course.
like the stories of, you know, tokens costing more than engineers, et cetera, et cetera. Um, and like OpenAI is acknowledging that, and they're like, we can't proceed this way, like foundationally. So they're looking now to start optimizing and looking at the value of a token. Like how can we get more out of a token? Which to be fair, I predicted on this podcast, you know, probably a couple months ago now, where we're at the point where the models are actually kind of good enough to do a lot of the foundational stuff, like engineering work that we're doing. So there's going to be a dramatic shift in resources to go from, okay, let's just run on generic graphics cards to, hey, let's develop very specific hardware and very specific, you know, pipelines to get the most out of each and every watt that we can. And therefore the scale required might, like, I'm not sure if this is going to lead to like the plethora of data centers being too much. There's a risk of that, where if they can figure out some of the compute requirements and get them down, you know, 100, 200, 300%, maybe we don't need as many data centers. I'm not sure. We have seen some evidence of data center builds stopping. I think it's something like a month ago or something, I was reading that 50% of the ones that were planned last year have now been like paused or something like that.
Well, I know that in my research, I was looking, one of the ones is in Abilene, I believe it's pronounced,
Mhm.
in Texas. It's called the Stargate data center, and it's like a campus of data centers, and you know, OpenAI is a part of it. There's a few other companies a part of it as well, but part of that project has been, you know, canceled or put on hold for sure, and I'm sure that that applies to many other projects as well. I think that even that, I mean, points to the scale of what we're talking about here, where people are worried about this, you know, one sort of data center campus, this one sort of data center cluster called the Stargate one, you know, in Texas. But yet, like this is happening all over the world. Like I mentioned,
Yeah.
you know, geographic availability, but also, you know, you need to keep go faster, 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 more and more and more. And I mean, all the problems that come with that are what's coming with these data centers, and this is why it's controversial. And I would actually like to say something. So I pulled it up, and this is one of my sources here. I pulled it up. This is from Hanwha Data Centers, and it says here, how much does, in the FAQ, how much power does an AI data center consume compared to a traditional data center? AI data centers typically consume 3 to 5 more power per square foot than traditional facilities. A single AI server rack requires 50 to 150 kilowatts compared to 10 to 15 kilowatts for conventional computing, driven primarily by dense GPU clusters that operate continuously at maximum capacity. Because you have to think about something else with traditional compute. So I don't know the official name of it, but when I was in the industry, in the IT industry, we used to call them archive servers, where a lot of these servers would actually go to sleep. They would go to sleep,
Mhm.
and there would be a network mechanism that would stay awake, and it would wake the server up. And it would just, the network, you know, appliance was very low power, and it would just sit there and wait. And then you'd be like, hey, I need access to that video file. And it would be like, yeah, okay. And it would wake up the server for you. So that server is using virtually no power or very little. And then you wake it up, and then it stays awake for a duration that you set, maybe 10 minutes or whatever. And every single time somebody hits it, it stays awake for, you know, another 10, let's just say, for an example. And then if no one hits it for 10 minutes, it goes back to sleep and it waits for someone else. Now, what that does is it allows you to use less power, especially on, the reason why we call them archive servers, especially on footage or media. That's commonly what we use them for. Footage or media and things that would be rarely used, maybe for like commercials. Let's say marketing makes a commercial, IT needs to store it somewhere, we store it there. You know, we don't need a lot of compute to store something that someone's going to access once in a while. And so that's why we do that. And so, like, you know, we have that. Now, the first person that hits that and wakes that server up, maybe they're waiting a minute or something for the thing to load, but that's a small price to pay for all the power that you're saving. But now we're talking about being, you know, just like we said, the power per square foot effectively, it's just kind of being completely blown out of the water here. Like this is a whole other thing.
I can't even imagine, by the way, any of these massive AI data centers having even a second of off time, because right now everything is just compute. Like they're if you look at the XAI data centers, if you look at any documentaries or any like podcasts on that or whatever, like I've watched a few and I've listened to a few, they're like, it's the most janky thing you could possibly imagine. These aren't traditional massive buildings. They're finding like factories for sale, and they're just like throwing racks in these factories, running cables like haphazardly through them. Like they're trying to like get these things up as quickly as possible, and it's as janky as you can imagine. Like there's cables everywhere. Like there's people running with these like massive server racks, like just trying to get them in because they're compute bound. Like every second that they don't have that compute is money lost. And so none of these servers are sitting idle unless they're broken. None of them. They're
Yeah.
like we're at the I guess the gold rush of tokens, or the gold rush of compute power.
Well, they're all
And
competing. They're all competing. Investors are dumping money in.
Yeah.
So they're just like, okay, bigger. Because the thing is that an investor right now, let's just say they give $1 million to OpenAI, and then OpenAI, you see that their growth rate of their compute power or other metrics that are around these sort of AI data centers, if their growth rate is 60%, I'm just making this up, 60%, and Grok is at 90, I mean, the next million probably wouldn't go to OpenAI. The next million would go to Grok. And so now they're competing for, in that side, in that way as well. They're all fighting. And I would like to say something. This goes beyond the scope of my research, but data centers switch their computers out. Like, you're talking about people putting it, racking GPUs, racking like servers, all the other infrastructure that goes around it, the power, the cooling, everything else, right? All these things to keep this thing up and running, and then the thing is obsolete in a year. The thing is obsolete in 2 years or whatever it is. Now, again, that goes beyond the scope of the research I've done for this episode, so I don't have exact numbers on how quickly they replace these things. But these aren't, hey, let's rush and do this now and rip off a Band-Aid, and then this thing will be there for 100 years. This thing will be there for 50 years. I mean, are you really going to be using a GPU to compute on an AI in 50 years? Like, probably not, right? I think honestly what we'll probably start seeing is that compute load distributed. There'll be some stuff that's running more locally. Obviously, we've already seen some models, like I know DeepSeek has a local version or whatever, and there's several other examples, neural cores. Everything is all gas, no brakes right now. Everything is all gas, no brakes right now. Around AI, around like trying to get neural cores into people's everyday personal computers. It's chaos. And if you've ever worked in IT, you would know, like, when something's all gas, no brakes, it's a mess. And that goes exactly to what Mike just said, where there's just cables going all over the place and this and that. And then the AI itself is a newer invention. The way that we're using it is like a newer invention. And so now that thing's making mistakes, and we're trying to like burn the candle at both ends or whatever, where we're trying to make it so that the compute load is distributed or whatever. And then we're trying to have enough AI data centers, and now the tokens are too much. So now we got to like go mess with this. Like, this is chaos. And this is what I meant is, like, as I started reading and researching this, like, I was actually sick when I was doing this. And thankfully, because I had a ton of time where I wasn't really working, I was just reading and watching videos, and I was like, this is chaos. Like, this is, unadulterated chaos. And what's the solution? I mean, one of the things I'm a little bit concerned about too, and I hope this episode, hits well, is I saw people complaining on a Facebook thread, and again, it's just Facebook comments, but people complaining about AI data centers. Fair enough. It was a story about an AI data center. But then I saw some people just complaining about data centers. And I thought, you know what? Like, we need a bit of consumer education here, because the fact that you've just commented on Facebook means that you've hit at least one data center. And like, people are not informed about what data centers are. Like, the term data center is a hot button issue now. And so now people are against them. Meanwhile, if you just said, okay, all data centers off today, our communication is going to be severely detrimented. Our services are going to be severely detrimented. And not only in terms of entertainment It's not like, oh, my ChatGPT doesn't work or my Snapchat doesn't work. Like critical infrastructure is going to be hurt by not having data centers. And we've seen that before data centers were sort of more public, if you will. When, like Mike, you mentioned like supercomputers, like back in the 80s, 90s, it was like IBM's supercomputer is capable of doing the job of 15,000 of your own personal computers. Those classic sort of like tech documentary, maybe even like on the news, like where they show like, look at all these computers in this building, because it's a new thing, right? It's like it's fun and it's exciting, but now it's like, let's not toss everything out with the bathwater here. Let's look at all the facts. Let's look at all the facts and see what the heck to do here, because this is a mess. And a mess it is. So I want to start, I think I was going to start with economic, but I think we'll jump into environmental impacts first. So data centers, of course, chew through a massive amount of resources, especially hyperscalers. And the two things I want to tackle is electricity and water. Two hot button issues. There's many other environmental impacts I'm aware, but I want to kind of zoom in on these two things. I'll touch on electricity right now. So for electricity, for example, some large data centers will have their own microgrids just to keep up with the demand, using on-site power generators such as natural gas generators and other electrical generation means in order to not rely on the local grid. So this is something where there's actually an economic / an electricity issue here, where if you have a data center that pulls an absolute massive amount of power, not only are you straining the grid, let's just say you're not straining the grid, but the demand for power just went up. And now everyone in the community, whether it's the city or the town, now everyone has to pay more. And so now there's your electricity and your economics start to go. You see where this is all going to be a big mess of a mesh, right? And so some of these facilities, like the Stargate data center, are so big that they can't. It'd be like, hey, I want to put a data center in your town. And they often do go to small towns because there's lots of land around. I want to go to do this in your town. Your town has 2,000 to 15,000 people, something like that. Oh, okay. Well, they can't connect to the grid. It'll completely tank the grid. The government or whomever is going to have to come in, start making more electrical power plants to power the grid. The amount of money for the electricity is going to skyrocket. You remember, these are small towns, small economy. Usually it's cheaper out there because there's less people, but also because the local economy is a little bit of, depending on where it's located, if it's close to a major population center or not. But if it's not, if it's more of a rural community, it's kind of an internal economy where it'll actually, people will work in the town and then they rent in the town, and it's cyclical, right? Well, the Stargate data center in Abilene, Texas, once fully constructed, will draw up to 1.2 gigawatts of power is what is supposed to happen. If you don't think that's a lot, I've been saying megawatts a lot. This is gigawatts, so it's much more. 1.2 gigawatts is enough to power 900,000 to 1.2 million modern homes.
That's a lot of homes.
And the Stargate data center is using a bunch of natural gas on-site generators. There's videos of it. I'll include the video that I watched include the video of the YouTube video I watched in the show notes. The thing here is that it's like a power plant. I mean, there's a bunch of stacks. They're in sort of like a little mini grid. And there was only one on in the video because the Stargate data center is still under construction, but maybe all of them will have to turn on at some point. And then you start having an issue where, okay, environmental impact. I mean, you're generating a bunch of power. You're using natural gas. You're throwing a bunch of particulates into the air, which of course is an environmental concern. I mean, just in our local area, we had a coal burning plant. It had a bunch of environmental things in the stack and everything, but it was still firing particulates into the air, at least at some point. And it got better and better as environmental, restrictions and environmental technology got better. But it's still gas, right? It's still, in that case, it was coal. In this case, it's natural gas. It's not using a solar farm. It's not using windmills. It's not using something like that. And I just briefly took a look at this, but it was something crazy. Like if you were like, let's do this via solar, it was like out to lunch. Like the amount of solar facilities you would need would be, ton of land, it'd be a ton of power. And so now in Canada, anyway, we're taking a look at making nuclear means. Like we're making some sort of mini nuclear generators here in Canada. It's one of our economic growth plans or whatever that our government is putting forth. And like that is because of data centers. And it's crazy. Like this is a crazy amount of power. And I'm not a guy who's like super worried about the environment. I'm not going to go out there and like dump diesel in my local river. I don't like things to be dirty. But I'm not a guy who's like constantly worried about every bit of power consumption, full disclaimer there. But this is crazy. Like the fact that when I watched this video, I was like, oh, like, it'll be powered by a bunch of solar or something. Before I jumped into this, it's like, oh, no, we have a bunch of gas facilities. And it's like, yeah, temporary, right? No. Fantastic. Fantastic. Just a whole bunch of natural gas, and that's not something I would expect. And it's not really the vision of the future that we see either when we see like videos, movies of the future and stuff. And I know it's just the movies and know it's just video games, but you don't really think, oh yeah, let's fire up the old natural gas plant or the old coal plant again or whatever to try to power these things. This is a massive amount of compute and it's a massive amount of electricity. Yeah. And because of the particulates, it can affect the health of the people in the area as well, depending on how that's controlled.
Yeah, and to be clear, they're firing up the coal plants. Like they are refiring up all the coal plants that they can.
I heard about that too. Yeah,
they can't like they don't have enough power. Like the U.S. grid can't handle this. This is why they're going to the like mobile stations. The U.S. grid cannot handle the increased power. It's going to take years upon years to update the U.S. grid, which like is kind of a side benefit. Like I'll like it's a little bit of a hidden side benefit, but it is a side benefit. The U.S. grid needed a massive reconstruction, and this seems like the forcing factor for them to actually consider that and put more nuclear plants up, put more hydroelectric plant. Like there is going to be some advantages to this, but it's going to take a long time, and there's going to be a lot of time where we're burning way more coal, we're burning way more natural gas and regular like diesel generate. Like there are some of these data centers powered by diesel generators. That is a thing. I believe one of the XAI ones I was reading about, at least temporarily, I'm not sure if that's permanent or not, or like longstanding, but they did bring on massive like trucks with like diesel generators in them, and they started like connecting them. So this is janky. Like this stuff is janky as heck. And the other problem, and I think you're going to mention this as well, but I'll kind of front run you on this, is that local governments, these small residential communities, they're trying to get these data centers in to boost their economy. They're in lieu of like doing environmental impact reports as thoroughly as they should be,
or pushing through permits or allowing things through, kind of like yeah, go ahead.
Because the data center companies are coming to them and they're like, well, if you're not going to do it this week, I'm going to get someone to do it this week, and then we're going to leave. We're going to take the project somewhere else. They're using their power to proceed as quickly as they humanly can because they're capitalists and they don't care about anything other than making money. That's their job. And the government's job is to push back, but they can't because now they're trying to fight their own people and make it so that they have more jobs. Now, the argument of more jobs and any benefits to the community from data centers is actually a very difficult argument. Like it's not a simple argument of like, hey, this massive 1.2 gigawatt data center that's going to generate thousands of jobs, right? Well, maybe for a little while
during construction.
But when a data center is built, you'd be surprised how little it requires to stay running. It's not going to take an entire community of people to maintain a data center. It's going to take some very specialized people from outside the community, most likely, and then maybe some, security and some grounds work and stuff like that, the community that can provide. But it's like, you're talking a handful of jobs on a long-standing basis. On a temporary basis, sure. Like to build it is going to take some time. But these are just warehouses. Like they're not some future high-tech space center. This is just like a big warehouse. Like it's not a complicated structure. They're being built as quickly and as cost efficiently as possible, and that means that there's going to be the minimum required jobs generated as possible too. So there's a lot. I'm not anti data center. I want to make that very clear as well. Is like I understand the need for them, and I understand that like to power the next part of the future, we might have to do things a little bit jankily as well, and I get that, but it will 100% have a negative impact on some communities. It will have 100% maybe health impacts to a certain degree on some communities. Like we'll see if that's ever going to be verifiable, because companies are very good at hiding those reports. But regardless, like, this is going to be a massive infrastructure build out. I believe somewhere I read, and I don't know if you came across these numbers in your research. Somewhere I read that this is the biggest U.S. infrastructure build out ever. Like, I think the one previous to that was the cross continental highway system.
I saw little like bits and pieces of like mentions
Yeah.
and stuff like that, little quotes like that. I also read, and this was before I did specific research for this, because I'm into tech and I've seen, data center articles and stuff. One of the things I read was that the proposed, and some of it's been cut now, but the proposed amount of money that people want to spend on these AI data centers is ever been generated by the electronics industry in total ever. So like everything from selling iPhones and iPods to MP3 players way back in the day and everything else. And so that was one of the red flags that I saw. And again, I just saw that in passing. I don't have a quote for that. It's kind of beyond the scale of my research for this episode, but beyond the scope of the research. But I saw like, little quotes like that. And it's just, and you're going to get quotes like that because again, this is an all gas, no brakes. We need to build this quickly. And like Mike, you mentioned that, possibly this will kick the power grid into high gear and it will like allow us to have a better grid. The problem is that it's all gas, no brakes. This isn't someone coming in and being like, okay, guys, we got in 10 years, we need another such amount of gigawatts. We don't have that. Let's plan and let's build this thing together. Let's figure out what we need to do. This is 1.2 gigawatts tomorrow night. And then they're like running around trying to, figure it out. And they're like, hey, get the coal power up, get the gas power, start dumping diesel in the river. I mean, just making that part up, but you know what I mean? Like, it's a very go, come on, faster, faster, faster. This is not a controlled, hey, we have a compute load that's going to come up in 10 years. How do we do this sustainably? How do we do this without destroying everything? How do we, including economy and stuff like that? Talking about destroying things, people are very concerned about water, another environmental impact. That's the last environmental impact thing that I'll mention in this episode. Again, there's a whole bunch of other things that we could talk about. We could have like 15 episodes, I feel like. But water, one of the major environmental impacts that people are very concerned about is that these things use water, but not just any water. A lot of them will use fresh water. Why do they do that? It's because servers are very hot. So think about your home computer. And if your home office is in a small room that's not very well ventilated, and you have a powerful computer and you're constantly doing something, let's say you're video editing, you're rendering, your computer is always kicking out heat. Well, I mean, I have a gaming computer to my right here. It's got fans all over the place. It's got heat sinks all over the thing. This thing gets hot. It gets hot, right? And if you didn't have cooling, it would melt itself. If it didn't have checks and balances and temp sensors and things like that to, save itself, it would just melt itself and it would potentially go on fire, right? It gets hot. And this is a personal computer. This isn't a supercomputer. There's only one computer here. It's not, 5 computers strapped together on a rack or anything crazy. So think about if you're in that little room, how hot it gets, right? How hot your office gets. I used to be in a tiny room for my office and it used to get hot. Even in the winter, it'd get really hot and you'd open the window in the winter air would kind of solve the issue. Well, take that example and extrapolate it by like 50,000 computers and computers that are likely more powerful than yours, likely running at a heavy load, possibly 24/7, lots and lots and lots of heat. Large data centers can consume up to 5 million gallons of this fresh water per day, which is equivalent to a 10,000 to 50,000 resident town. Up to 85% of the water used in cooling towers evaporates into the air. So it's not like they're dumping chemicals in it during the cooling. It's like it's hot air and then they're kind of discarding it and it's naturally evaporating, which is good. But the problem is, because I thought it was good. I was like, oh, it was evaporating. That's great. The problem is it is not being returned to the local groundwater supply. And oftentimes, not always, but oftentimes it is pumped from the water table beneath. And so now you have this huge amount of water being pumped out of the natural water table for data centers that weren't there before, or maybe are being expanded, right? So now we have a bunch more of this load. And when that water evaporates, it doesn't necessarily mean it's going to rain back down on your town. And that's something I didn't consider. Off the top, I was like, hey, because people were freaking out about water. And before I educated myself, I thought, well, they're not dumping chemicals in it in the middle of the cooling process. Obviously, they're not doing something silly like that. Why does it matter? It's still okay. Maybe it's gray water or something and needs to be treated, but it's not toxic waste now or something. Who cares? And then when I read it evaporates, oh, sounds great. It evaporates, natural, the planet will sort it out kind of thing. And then you start thinking, oh, hang on, what if I'm in a drought and this thing's pumping a bunch of water out of my water table and all this is getting evaporated and it's raining on the neighboring town and their water table's doing great and ours is not. What are we going to do? Because we're pumping water like crazy. And this is a problem. And they're tackling this. They are tackling this. One of the ways they're tackling this is they're looking at building in different locations. So obviously Texas, we mentioned the Stargate data center there. That it's very hot in Texas. So I mentioned opening that window to your home office in the winter, and especially in Canada, and that kind of solving your issue. It cools that room down after your computer's been running all day. Well, they're kind of taking that concept and applying it to Canada. So the prairies here, if you don't know what they are, they're more Western Canada. Saskatchewan and Alberta are part of the prairies, for example. And I think Manitoba might be part of the prairies too, but Saskatchewan and Alberta certainly. And the point is that the prairies are very, very flat, very, very flat, to the point where the meme is if you're taking a road trip out to Western Canada, you better have a good podcast on or something on the radio or on your car's audio system, because you're going to fall asleep because it's so boring, because it's so flat to drive on. And obviously that is great for farmland. You got a bunch of wheat and stuff being farmed out there, a bunch of other agriculture, a bunch of things like that out there. It's also really great for data centers. Why? It's in Canada. So Mike and I live in the southernmost part of Canada. So we get, the warmest temperatures on average. Weather's, variable. And so we get a hot summer and a cold winter. But because we're in the most southern part, in Saskatchewan and in Alberta, in Manitoba, in those provinces up there, they're the most southern points of those provinces are still more north quite a bit than us. So for example, while they might be getting snowstorms in October, I'm golfing outside till November or even into November. So there's a bit of a climate change there. And so of course, you have that flat land, you're quite north. You do have infrastructure up there because people live up there. And so what happens is people are now starting to look at building data centers out there. And this is partially because they're trying to lower the amount of requirements on the cooling, such as the water and things like that, the water that they need. Because they can kind of do, obviously on an industrial scale, but they can, if it's really cold outside, because it gets cold in Saskatchewan and Alberta and Manitoba, it gets very cold during the winter. It's cold for, let's say, 6 to 8 months of the year, again, depending on the weather that year. And so they could potentially not need as much or any water during during certain cold snaps. So they'd be able to figuratively open the window and have the servers be running. Now, obviously, there's going to be fans and industrial systems controlling that. It's not just going to be them literally opening a window. But the thing is like they're working on it, but it's still like to give you a, kind of a snapshot of the scale of the cooling that's required. And I mentioned Mike and I get hot summers. Those prairies get hot summers too. And so they still need water coming in. And now I will say, like, there's projects out there. So Kevin O'Leary, if you know him, or Mr. Wonderful is his nickname. He has a project called Wonder Valley. By the way, Mike mentioned this. An environmental impact assessment has been waived by the Alberta government for that particular project. Whether you agree or disagree with that, that's what's happened. But the thing is that it needs fresh water to cool down. Now, it does use a closed loop system, so it doesn't need to be constantly refilled. So in many of those systems I already mentioned, where it's like consuming that water and then it's evaporating out, they constantly need to pump new water and then they kind of like get rid of it. In a closed loop system, you basically like fill the tank. It's sort of like if you have a water cooled computer. That's a prime example, where you're not constantly filling up what's called your AIO, your all-in-one cooler for your CPU. It has water or some sort of coolant solution inside. And then it goes through a radiator, gets cooled by fans, and it comes back to the CPU, gets hot again, and goes through the radiator. And so it's something kind of, again, similar. It's at a massive scale, but it's something similar to that. So, they're working on the water issue. Obviously, they're working on the electrical issue. Thing is, though, there's still issues, especially since it's all gas, no brakes. You have to think. It's not like they built a whole bunch of stuff right this second, and then we're like, okay, we have to play catch up. We're still building. Like, we're still freaking going. So it's like, oh, okay, now we got to get more water. We got to do this. We got to do that. We got to go over here. We got to go over there. I mean, what's going to happen to one of these data centers if it is pumping water out of the water table and there's a drought? Are they just going to shut that data center down? What does that data center do? What does that data center do? Like, think about the compute. Is it all of OneDrive? What is it? Is it a key component of Google Drive? Is it a key component of Gemini if it's an AI data center? What is it? And so we need to, really consider this. Like, this is a serious thing. And you could connect to the grid, the water grid, I mean. So the water plumbing, if you will, whatever. That's a big ask, though. Again, it's not like just because you've plugged into the local water infrastructure that all of a sudden, you're good. That water still comes from someplace, like the town, city, or municipal area, the county is still getting that water from someplace. And so, like, they don't have an infinite supply just because you're connected to that water grid. And so it's a huge problem. And then you have, what if there's a bunch of wastewater that they dump out? Can our sewers handle that? Like, we're pushing it, man. Like, we're pushing our infrastructure. We're pushing it. Going full, again, keep saying it, all gas, no brakes, but it's serious. And until I did this research, like, I kind of knew it was going pretty quick, but it's fast. It's going nuts.
It's it's a very different it's a very different thing that we've ever seen before in our lives. I think this build out, the amount of money alone, it's just astronomical amounts of money. Like, we're like talking trillions, I think. At one point, OpenAI, Sam Altman was saying like he needs to raise like $5 trillion or something insane like that. I don't know if that was like a hype thing or whatever, but that's an insane amount of money, by the way. Like, that is an absolutely ridiculous amount of money. Now, to be fair, a lot of that isn't just the data center. It's more like actually the graphics cards that are required to power the data center. Like, a big chunk of that is that. Like, building the data center is actually not that expensive compared to the compute required and the constant upgrading of compute that will be required for that. Like Matt was saying, these aren't like one and done things. Most likely every 3 to 5 years, you're going to need to do a massive overscale, like over upgrade. And especially now that we're in the early stages where we're using very general compute, like all of these NVIDIA GPUs, they're very general compute. Like, you could take the NVIDIA GPUs that we have in the data centers and put them into your home computer to a certain degree and game on them. Like, that's a very direct, like, general compute problem. Whereas, like, potentially what's going to happen is they're going to develop GPUs or like maybe just data processing units, like some sort of other NPU, whatever they're going to call it, an ASIC of sorts, so that will be just good at AI and only AI and nothing else. So there's not going to be any waste for other things. So all of the development will go into that, or the board will be designed for that. So that might require like not just like a switch and replace. That might require like all the racks to be changed because maybe there's some optimal layout for that to work. So we're talking an ever increasing budget for this data center to keep up with the compute. Like we're seeing numbers thrown around at scales we don't fully comprehend, in my opinion. Right now, Anthropic and OpenAI are bordering around the $1 trillion mark in terms of valuations. For like such an early stage company, these aren't like 20-year, 30-year, 50-year, 100-year conglomerates. These are like new startups. Like, these are startups. They are not IPO'd. This is an insane growth, and they're not like we're valuing them as if they're going to be infrastructure providers. That's why the valuation is so high. Not at the current capabilities. Obviously, we're always valuing at the future, and what they're saying in the future is that everything will run through them, right? Like, all compute will run through them. Like, your every computer that's sitting at your desk is going to hit those data centers and hit those companies, and that's why we're valuing them so high. So from that perspective, like, this is just the beginning. All of what we're talking about is just the beginning.
Well, think about this too, is we had a ramp up when it came to computing. Like, it was sort of like, all right, the local home computer, the local home console for gaming, and then it was like, hey, we're gonna have these things be more online. We're gonna have online websites and things, and so the data centers start coming about, and then it's like, hey, the browser is pretty powerful. We could have different things on the browser. We could have photo editing and stuff. And then the person's computer doesn't have to be amazing. They don't have to have an amazing computer at home to run Photoshop. Maybe they can run a bit of that Photoshop stuff on the cloud and things. And we had that sort of like more or less like slow ramp up. This is like 3 years ago, 4 years ago, we weren't talking about AI. Like I said, listen to that hyperscale podcast, or that the podcast was talking about hyperscalers. They weren't talking about AI. They didn't know anything about it. And now, if that podcast was filmed today, they'd be only talking about AI. They'd be like, I have a 30 megawatt AI thing. I have a 1.2 gigawatt, blah, blah, blah. You know, it'd be all AI. So like, there was no ramp up for AI. It felt like it was just like, and up, like right up all of a sudden, right? And we're using, like you said, general compute, like you said, Mike, but we're also using general construction. We're just using our means. We understand data centers for traditional data centers really well. So we're only using our own knowledge to go as fast as we possibly can. But then you start getting these other things that creep in, like the neo clouds is an example of something creeping in where it's like, maybe there's better ways to do it. And that can really disrupt things, especially when maybe we like have everything on racks. Like I've been in data centers where the whole floor, all the tiles on the floor are perforated. And the reason why they are not perforated, had holes in it. And that's because like constant cold air from an AC unit, an HVAC, unit is being pumped through up through the floor, and that's how things are cooled, right? And the servers themselves have fans to help sort of locally at the really close to the servers pump the heat away, and then the room is being cooled by this constant cold air coming out of the floor. That whole idea might not be the greatest idea for, like you're saying, Mike, for AI. And so if these new chips come out or whatever, and it's like, hey, these all need to be vertical instead of horizontal or something. It's like, oh, great. So now the rack's got to go. Maybe that floor all has to be torn up. We need a new HVAC system, whatever. And it is because like, we don't have this, like, obviously when we start something, it's inefficient. Obviously, we like our cell phones used to have a brick of a battery that's bigger than a cell phone today. Like just the battery of the cell phone. We had cell phones like in Wall Street or whatever, like the movie Wall Street. We had cell phones back then that were extremely inefficient because it was the first versions, but we also ramped up. Not everybody was having cell phones. The rich Wall Street guys had cell phones. The critical infrastructure guys had cell phones. And then slowly we figured out how to make cell phones better and better and better. And it kind of ramped up. But for some reason, it just will like this, not some reason, like we know the reason. It's because there's a bunch of money being dumped into this. And so there is no AI ramp up. It's just boom, let's go as quickly as we can, as fast as we can, go, because it is a race. There's a bunch of environmental stuff or a bunch of investment stuff going on. Mike, you were mentioning, $1 trillion or whatever for Anthropic and whatever. I just looked it up here on macrotrends.net. Walmart Incorporated net worth as of June 2nd, 2026, just over $1 billion.
Wait, no, Walmart's
hang on. Excuse me. Made a mistake. Yeah. Sorry. Just over $1 trillion is what I meant to say. Just over $1 trillion. Yeah, sorry. I'm going to read this. This is why I made a mistake. It's 10.66 billion. And I thought that was, I messed that number up. Yeah. So just over $1 trillion, excuse me. So we're talking about Walmart was an established company that like started slow and did this ramp up. I don't recall, there's probably an example, but I don't recall an industry that's ever really done this, where it's just been like, like the graph, like straight up and like, hopefully it tapers off at some point, like at some sustainable point, I guess.
I think if Anthropic IPOs at $1 trillion, they would have to be the fastest growing company ever in existence by like such a wide margin. Because Anthropic, to be clear, was established in 2021. OpenAI has been around for a little bit longer. I think it's 2015 or something like that. So OpenAI has actually been around for a little bit longer. They were like a research lab, a nonprofit research lab for a long time. It's 4 years old.
So this is just an AI overview, just to give us some numbers. Anthropic is a privately held company, so it does not report a traditional net worth. However, following a $65 billion Series H funding round, the AI developer now holds a massive $965 billion valuation. Walmart, in all of its glory, that sells to virtually everyone. There are Walmarts everywhere. And I believe Walmart Inc., I don't know how they've split their valuation because there's Walmart Mexico, there's Walmart Canada. I don't know all that
That's one
stuff.
evaluation.
But like, that's crazy. Like Walmart of all things, you'd be like, oh, that's gonna, that's like maybe I'll catch up one day, but not today. Well, they kind of have. I mean, it is a 40 billion discrepancy, but it's or maybe 400 billion or whatever it is. It's a is it 40 billion? Yeah, $40 billion discrepancy. But
I mean, it's all kind of fake money right now because, like you said, it's a private org, so we don't actually know what it's going to IPO at. I want to make that clear.
Yeah.
And there might be a complete, collapse or something like that when it IPOs. It's totally possible. But it's crazy that we're even talking about this comparison. Like, in my opinion, that's just insane. But again, it's not because of what they can do now. It's that we're seeing in the future, potentially they're going to be operating everything. Like, everything. Like, it's not, they are going to be like a power provider. Like,
well, because Sam Altman kind of said it's like how you have electricity and water pumped in your house, you'll have an AI pipe.
Something
figuratively.
like that, yeah. It's crazy.
So, like we've touched on environmental impacts, electricity and the water. We touched on some of this other stuff. I have two more sort of areas to cover. This might be a bit of a longer episode, which we kind of knew because this is a huge topic. Economic impacts. So let's just jump into this. So this growth has been so explosive in AI data centers and AI stuff that we're seeing solid state storage and RAM prices soar, causing common household tech like the Steam Deck, which we covered in a web news, the PlayStation 5, and personal computers to increase in price by a lot. Mostly because these AI data centers are ordering equipment, meaning RAM and all this other things, years or months in advance, claiming stock that hasn't even been manufactured yet at prices that have increased significantly due to, of course, the rule of supply and demand. Critics argue that this alone could completely crush the consumer electronics industry. Others say that this is the natural progression of tech, however, as computing moves more on the cloud rather than locally, which would leave us consumers with simple terminals that can do little else than log into a remote system somewhere. So if you don't know what that means, just a brief kind of example. Right now, you buy an Xbox. Let's say you buy your Xbox Series S, and then you also buy an Xbox Series X. The Series X is the more powerful unit. The Series S is the less powerful unit. That's dictated by the internal computing components inside of the actual Xbox that you purchased. A terminal would be something that is really weak. So it has very little internal components that, generate heat or anything. It doesn't really compute much. Maybe it has a brief, an easy to use UI, and it has a good network card. And then you stream a game from a data center instead. That would be an example of like a terminal Xbox, if you will. So this is another big thing where, and this is I think where a lot of people started getting annoyed, because you kind of have a cost of living crisis where especially in Canada, we got housing issues, which is another thing that's taking a bunch of water, by the way. Waterloo, which used to be or maybe still is, I don't know, our Silicon Valley here in Canada, they're reporting they're running out of water. They said like one water main break or one major fire, and they won't have enough water in a given day. They're using something like 97% or something like that of their capacity each day. And it's a multifaceted issue. You have to remember here, this is a Silicon Valley area. And I'm not saying that it's due to a data center. I haven't fully looked into this. I just saw the news today. So I'm still reading the article. So I don't know if it's because there's a data center in Waterloo that's doing it all or anything. That's not what I'm saying. But one of the things that was mentioned so far in my reading is because they're building a whole bunch of homes. And now the homes have stopped. Like the permitting for the homes has stopped because they're trying to deal with this water issue. So now you have to look at this another way where it's like, okay, now we have a serious problem where like other economic issues that are not related to AI at all also use electricity and water. And these other things are going nuts too. And so now everything's like really straining the system because like we have homes here that are, here's a little tiny home, $1.2 million. Why? Just because it's Canada. And like, so if they want to build more homes for supply and demand to lower the prices of homes because people aren't buying homes, they need to use more water. And so if our infrastructure can't keep up, or if the water table can't keep up, or however our water is, figured out, because I'm not a water technician, what happens if a data center shows up and says, I want to build a big old data center here as well? We like, this is, and you're starting to see people get pissed off, obviously, of course, because the electronics are going up in price. You have a house because that's why it's all married together, because it's the houses are super expensive. It's a cost of living crisis. So they're trying to build more houses. They're messing with the water. You got all these, AI data centers running around trying to do stuff. So they're straining things. Now I can't buy a Steam Deck. And like some of the comments on our previous video were like, oh, you don't need a Steam Deck. You don't need this and that. The point is not like, do you need that thing? I could live like, Jacques Cartier and his, fur traders or whatever. Like I could live in tents, I could do, we could do that. The point is that there's like a modern sort of standard of living, and you kind of generally want your people to have a modern standard of living. You don't want most people living in terrible conditions, barely making it. That's not the point, right? And that includes luxury items. Obviously, there's budgeting and things you can do. And, if you can't afford a Steam Deck, then you can't afford a Steam Deck. And that's unfortunate. But it is a detriment to the quality of life. Whether the official government metric counts that or not, I don't know. It counts entertainment, but it is a detriment. Like, oh, I can't afford a game console. I just work all the time and I barely pay for anything. That's at the very least, a personal quality of life issue, right?
I think it's a happiness indicator or something like that. Like there is that
happiness indicator for sure.
Yeah. Mm-hmm.
Yep. And so you start seeing how like all these things are tied together. I mean, I would never, if you were like, hey, data centers are going crazy, we need to generate more power and water, I would never ever be like, hopefully my PlayStation 5 doesn't go up in price. I would never think that. Yeah. Now all of a sudden it's like, by the way, we also need all the RAM. Oh, here we go.
Well, it also doesn't help that every one of these AI CEOs is coming after our jobs. They're just like, we're going to replace this profession. We're going to do this. We're going to make robots that replace these guys. Like their whole marketing thing to get investors to invest is that we're going to lower your costs by replacing the people that you're hiring. And so like when an AI data center gets into a neighborhood, you like you can't afford a new computer. You can't afford electronics anymore. You can't afford housing. Your water might get screwed. It might not. I don't know. Power might get more expensive. It might not. I don't know. And then you're also taking up a bunch of land. It's ugly as hell. It's all jankily put together. There's like shit being put into the environment. And then you also, on top of that, are trying to take our jobs. Like that. Yep. That's the messaging that they're sending us directly. That is they're sending it publicly. This isn't like a hidden fact. This is all happening in the public forum. And then they're like, well, why are people against data centers? Well, like you're giving them no choice. That's the only way that they can fight back at this point. There is no other option. Like we can't like go and like, fight Anthropic. Like we can't sue them. There's nothing we can do. But if a data center comes to your neighborhood and you have the opportunity to go to a forum to vote against or for it, yeah, people are going into those forums and they're mad.
Yeah.
It's obvious. Like it's an obvious thing. And now you're seeing like the last 3 weeks or so, you're seeing all these AI CEOs start to like, oh, no, it's not going to take people's jobs. We're seeing the data is just suggesting otherwise. Like they saw this happen in real time and they're now trying to pivot away from it. But like to some people, it's going to be too late. But like it's weird that they would even think that this would go over well. Like it's an insane thought to me.
Well, there was a video I watched as well, which I hopefully linked. I watched so many things. There's going to be a list of links, like a big old list of links of stuff that I touched on and watched and things, and hopefully I got it all. One of the things, Mike, you mentioned this, is you were saying that in order to construct the data center, there's more people that are needed, and then to keep it up and running, you have less people, which I mean, happens in other industries as well, whatever. The problem there is because they're going to these small municipal environments, these rural towns. One of the big issues is there's no houses. Mm-hmm. So then you have this issue where, well, I'm a construction worker and I'm only going to be here temporarily, but the temporary thing might be 5 to 7 years. So now we have an issue because I need a house. How many of me are there? How many plumbers? How many electricians? How many power specialists? How many IT specialists? How many of this? How many of that? And so you start seeing houses get scooped up, including from people who are very capitalistic, buying the houses and then renting them to the people, renting it through Airbnb or just renting it to the people. So now the local residents, because many of the talent that's used in these construction sites, some of them are going to be local residents, 100%. But many of the local residents that work in that internal sort of cyclical system where one of the examples I saw was it was a caregiver that cares for his seniors and other people inside of the community. They were unable to find a place reliably. And one of the issues is it's because a bunch of these construction workers, electricians and plumbers and blah, blah, blah from out of town are now renting long-term Airbnbs, and they're all staying in a house, and they're all staying there. Now the housing price is going nuts because people want to buy the houses there because they want to rent them out, or there's just so many people buying it. And so now you have an increase in artificial demand on the housing prices in the area. And so you have this other issue where these small municipal communities of, let's say, 2 to 15,000 people, now a house that was 200,000, what if it's now 300? What if it's now 500? And you had this issue in Canada, widespread for the most part in Canada, like the whole country. Now these little communities are going to see it. And so now the problem is like, if I'm a person that lives and works locally, I was getting paid $15 an hour, let's just say, I made enough because it was fine. My community is kind of cheaper, but I live and work here, so who cares? And my money's cyclical, goes back into the community, and then the community pays me. Fantastic. Well, now I can't live here.
Yep.
And what does that do to the community then? Like, do I go to another town when I got to drive back? So then do I now take my money and say, the heck with this, I'm going to another town and I'm just going to work in that town? So now what services and issues and things do we have in that town? What holes in do we not have any retail workers in this town now? Like, that's not good. Like, this is the
interesting thing is that this could all be figured out. Like, you could figure this stuff out.
Oh,
like,
assuredly.
Build temporary housing, find local cities and partner with a million different ways you could figure this out. The problem is that the data centers or the companies that are building data centers have no time.
There's no time.
So they're like, all of their money is going into lobbyists that go in and try to get it done as quickly as possible with as least regulations as possible, because if they spend a second longer and they don't have the compute up at the exact moment in time that they need it, they could go under. Like, their whole business is centered around getting these data centers up as quickly as possible. And so they're from their own survival aspect, they can't worry about this stuff until it becomes a problem. And their response will probably be like, we'll fix it when it becomes a problem. Sure.
Right.
Okay. Like, that might be a response, but like, to the people that it affects in the immediate term, they're going to feel that hit.
Yeah.
They're going to feel it. And you're saying that, like, we'll figure it out isn't going to help them in their, like, whatever year or 2 years that it's going to take for you to figure it out. It's tough. It's a tough sell. And like, their perspective is like, we can't wait. Like, we can't do anything. So like,
well, you can't wait because you're competing. If Grok
Correct.
waits and OpenAI does not, then ChatGPT is now 2.5 times better next year.
Mhm.
Just making up numbers. 2.5 times better next year than Grok.
Correct.
So guess what everyone's going to do? They're not going to pay your $20 or whatever it is a month.
Mhm.
They're going to go to ChatGPT.
Yeah. Like, it's a very difficult situation. And like, the government usually is the one that's trying to handle this, but right now it's in a little bit of a disarray. So like, they're going to take advantage of that. They're going to take advantage of the situation, obviously. And so that's what we're seeing. We're seeing the advantage, like, people being taken advantage of. We're seeing municipalities be taken advantage of as to the maximum effect of their effectiveness, like as much as they can pull out of that community. They're going to pull out with subsidies and with whatever. And so like, it might be a short-term. I don't know if it's going to be a long-term issue. It might be a short-term issue. It might be long-term. Who knows? Because it depends on how the response happens.
I think it's going to be. I think it's honestly going to be short term, but not short term as in next year. I think in a decade at least, because we're burning the candle at both ends of the thing. I think we're going to have more efficient chips. We're going to figure out how to build AI data centers better. We're going to figure out how to cool things better. I think we're going to figure that stuff out to such an nth degree, where it's going to be like, okay, like I at least I'm positive in that regard. Like, I'm positive thinking in that regard. But it does suck that basically in the short term we're just sort of scuttling, these communities and scuttling these concerns. Like, it's not, it's not great. I mean, like, one of the major concerns, and I see, people for and against this, is many of these people that, like, they bought a house and they wanted to live rural, and they always did. And now across the road from their house, they have this big data center. Some people would argue, well, like, that's a free country. That land could have been bought by a golf course. It could have been bought by a Walmart. It could have been bought by anything. So if you want to live rural, then I guess you're moving. And, and that still sucks. That's why it makes the news. It still sucks that they kind of all of a sudden get hit by this huge thing. But then you have another issue where, like, sometimes they're hit by more things. So a lot of the times, data centers will make like a noise and like there's a constant hum. Now, whether that's due to the microgrid running or the water pumping or the constant construction or whatever it is, if it's a constant noise that literally is going to be on even when it's been fully constructed, that really sucks. Like a constant hum. And sometimes there's other issues too, like their water pressure will get hit. So let's say the data center is connected to the local water grid. A lot of the times, municipalities will have like a standard, and they'll be like, water pressure needs to be between these two numbers. Well, let's say you were always sort of smack dab in the middle, or maybe on the higher end, which is better, arguably, in terms of water pressure. Now you're right down by the bottom. Oh, the water, the data center is taking all the water, so now you have barely any water pressure. Well, that is a quality of life issue. Maybe it falls within the local guidelines and things, and you're going to have to fight politically and all the rest of the mess. Still sucks. I lived here. It's like I'm not worried about my water pressure every day. I'm not thinking about my water pressure every single day, and all of a sudden I don't get any water pressure. And now it's like, well, great. So like now what do we do, for taking showers and stuff like this? And I do want to say as well is that each of these projects is unique. Like there's going to be some data centers, I'm sure, where they're going to be praised for being, smart, built, with concern, tried to hire local, all, the list of things. There's every single one of these projects is unique. Didn't use natural gas or only use natural gas temporarily until something else came to be about. Something, right? There's going to be, like, after the dust settles, because this is so chaotic. After the dust settles, you're going to see, some good stories out of this, some good news where, hey, this is a data center where there's 100 more jobs in this town and people like it here for some reason. And, here's the reasons why. And you're going to see those stories. I'm convinced. But for right now, because it's all gas, no brakes, like it's chaos. Like it really is. And the final thing here, because I've kind of like melded the economic impacts into the local municipal impacts, just because they're so closely tied. And one thing that I did read is that a lot of the time the data centers are actually not paying barely any tax revenue. Now, this is going to be a per jurisdiction, per state, per province, per county issue. So not every data center, again, is going to, be doing this. But what some people's complaints is that these data centers are popping up in their town, causing all this disruption that we discussed throughout this episode. And then the residents are still fronting the bill for all the tax. Like they need to put, they're the ones that are so responsible for the schools. They're so responsible for the water. He's so responsible for this. If we have this huge generating source of tax revenue, things are either, maybe the residents are going to have to pay less tax, or things are going to get way better where the residents are still paying the same amount, but now the data center is adding their amount, and the schools are amazing here, and the water pressure is amazing here, and the electrical is amazing here, and the roads are awesome, and you kind of get what you pay for. And unfortunately, due to, again, local regulation, which unless you go project to project, it's kind of a moot point. You can't like be like, in this county they're doing this, in this county, in every county is going to be slightly different. In each province and each jurisdiction, but it's still a major concern because if they're trying to dodge permits and environmental surveys, like any business, you're going to try to dodge taxes as much as possible. But I think that's it for the concerns in that. Obviously, there's going to be a ton more concerns, a ton more things that I didn't cover. Again, might have another data center episode if you guys are interested. Please comment away. I know there's going to be lots of charged comments, I'm sure. Or charge DMs that we get and things. And like, good. Like, let us know, like, should we really cover something? Cause I am considering doing another episode because I had so many, sources and things to watch and so many things to read and things. But Mike, this is your request. You wanted me to cover the types of data centers, and I don't mean data center hyperscalers or whatever.
I would say we should leave this actually for the next episode because I have a lot to say on this and we're already at kind of time for me specifically. Okay. But I do want to cover the different types of data centers from a like theoretical perspective. There's these theoretical data center types like space data centers and underwater data centers is actually more real. But like the space one specifically, I wouldn't mind having a whole episode just talking about how space center data centers are such bullshit. But let's leave that for the next one. Or
because I actually disagree with you, so that'd be a good. That's fine.
That's gonna be a good conversation then. I'm excited for it.
Yeah, so maybe another episode or maybe a web news or something. We'll discuss that down the line, different form factors of data centers. But that's it. Please let us know what you think about data centers, what you thought about our coverage. Should I cover something more? Should I cover something less? Et cetera, et cetera. And I have, again, a ton of stuff here A ton of links. I'm going to be including these in the show notes. I did not cover everything in these. Many of these things are, really big blog posts or really big reports that obviously would be a whole episode in amongst themselves. Excuse me. So please, if you're interested in anything we touched on, there's going to be more information inside of this, including the Jevons paradox, which is something I'd like to make it into the next episode if we do one. Please let us know in the comments and stuff. But that's it for this episode. If you want to support episodes like this, you can do so. And that's on Patreon, patreon.com/HTML, all the things, just like these fine people did. Tim from the Web Hacker on thewebhacker.com, Jason from Geek Life Radio via geekliferadio.com, Garrett Segal, Level Up Financial Planning via www.levelupfinancialplanning.com, Magnus from YesWeb via yesweb.se. It's a good thing we're stopping because I'm starting to cough. Magnus, I already did Magnus, excuse me, but I'm going to say it again because I lost my place. Magnus from YesWeb via yesweb.se, Syntaxify from the HTML All the Things Discord server, and Stacy Mostler from the website swoonworthydesigns.com. And remember that we have a Scrimba discount link. It's an affiliate link. You can get up to 20% off Scrimba Pro plan there if you want to take on all their courses, some front end, some back end technologies with their interactive media player code editor, learn how to code, guided by several great instructors in there. That link again in the show description and in the show notes with full details on how it works in the show notes on htmlallthethings.com. And last but not least, I'd like to give a shout out to Michael Araka, a contributing author on htmlallthethings.com. Michael is the author of Self-Taught the X Generation blog at selftaughttxg.com. Feel free to leave a comment or review on the platform that you're listening to this on, and we are signing off.